All right, guys. Question 1. Question 1A. How many cards are there in a standard deck of cards? So there's how many? Yeah. There's 54 including jokers, so not including jokers, 52, okay? So this page here is just kind of it's reference. So when we do some of these questions later on and you kind of can't, maybe you can't remember how many of certain suits are there or whatever, you can come back to this page, all right? So there's 52 in a standard deck of cards. So when we say standard, we don't include jokers, okay? 52. How many suits of cards are there? 4. What are the names? Clubs, spades, hearts, and diamonds. And good. How many cards are red and how many are black? So yeah, it's half and half, right? So 26. How many cards are there in each suit? We can have this again, and there are 13. I was reading the other day that maybe cards kind of came about because of the number of weeks in the year. There are 52 weeks in a year, 13 weeks in each season, and each suit represents a season. Thought that was kind of interesting. What are the face cards? What are the face cards? Jack, Queen, King. Some people include aces, but we're not gonna. So Jack, Queen, King. So there are 3 in each suit, so there are a total of 12 face cards. Okay. How many digits are there? 10, thank you. How many digits are odd? So we have 5 odd and 5 even. We're going to include 0 as an even digit. Okay. What digits at the end of a number make it even? No, there are 10, including 0. So now we're switching to numbers. So this was cards before. Now we're switching to numbers. Yeah. So what digits at the end of a number make it even? Okay, so if you can divide a number by 2, that makes it even. But what digits at the end? Right. So 0, 2, 4, 6, 8. So if this digit is in the last position of a number, right? So maybe it's a 3-digit number. It only depends on the very last number, right? To make it an even or an odd number. And what digits make it odd? So this is the other ones. 1, 3, 5, 7, and 9. And look at that. Done 1 page already. Yeah, we'll do it. Don't worry, Sawyer. How many letters in the English alphabet? 26. How many are vowels? And we have A, E, I, O, U. You know, sometimes Y, but we're going to just leave it with these 5 here. And then how many are consonants? The rest of them, 21. Okay. And with dice, how many numbers are on a die? We have 6 for each of the faces. And also, just so you know, the opposite faces on a die, they always add up to 7. Okay? So 1 is across from 6, 2 is across from 5. So that's how you can tell if there's a fake die. And what is the largest sum you can get? 12, yeah. And the smallest? 2, good. 1 and 1. Good. So for this next part, we're going to kind of work in partners. So what I want you to do for number 1, guess for this. When 3 coins are tossed, so if you toss 3 coins, what is the probability that exactly 2 result in heads? Take a guess. Just try to think about it, take a guess, and write it down. What is a probability? Okay. And then for number 2, we've got this chart here. What I want you to do is get in a group of 2, and we've got pennies here. Flip 3 coins, and then write down, what is your result? Okay, what is your result? So maybe it's heads, 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 or tails, heads, heads, or whatever. Write the results here. And is it exactly 2 heads? All right. So if you don't have a coin, you can take one of these, and you can pass it around maybe. Thanks. So take a coin and pass it around. Yeah. So let's start with this group over here. How many trials did you have with exactly 2 heads? So count up all your yeses, okay? How many trials did you have with exactly heads? 12, and you did 20? Okay, 12 out of 20. Okay, these guys, yeah? 13 out of 20? Okay. Isabel? 8 out of 20? Yeah. Okay, Maddie? 10 out of 20? Okay, Kai? Were you guys 4 out of 20? Wow. Okay. It's an outlier. Any other groups? Okay, yeah. 10 out of 20. Were you guys all in a group here? Or? Oh, okay, good. 8. 8 out of 20. Okay, 8, same group or different group? Okay, 8 out of 20. Okay, Dean? 7 out of 20. All right, sorry. 5 out of 20. Kristen? Okay, good. 6 out of 20. And one more group, right? Were you all together? 10? 10 out of 20. All right, so what we can do, we can add up all these numbers. So we've got 20 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 240. We've got 240 total trials. Okay, so these are the total, this is a total number of trials. And how many have favorable outcomes? Does anyone have a calculator and they would feel like putting in these numbers? Dean, do you mind? Thanks. I'm not sure. We're just letting Dean add it up here, so just let me know. 101. Interesting. All right, so we've got 101 outcomes with this favorable outcome. Sorry, we've got 101 trials with this favorable outcome. So we can use these numbers to find what we call the experimental probability. Okay? So the experimental probability is 101 out of 240. Okay? 101 out of 240. And if you use your calculator, you can find this in percentage. Okay? 42%? 42% equals 42%. So that's a experimental probability that we found. And that's what we've done here. We've calculated the probability. That's number 5. You can put it in as 42%. And for number 6, we're gonna find the theoretical probability. We're gonna use a tree like we did last time. So when we've got this coin flip, we can go either heads or tails, right? For the first coin flip. Same for the second. We can go heads or tails. Heads or tails. And then for the third as well, we can go heads or tails. Heads or tails. And then we can write out the outcomes. So here we've got heads, 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 tails, heads, tails, heads. Do you see how I'm getting these there? Okay. Next, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. Okay? And we can look at these and see which ones of them satisfy our conditions, right? 1, 2, 3, 4, 5, 6, 7, 8. So tails, tails, heads, heads is right here. Right, exactly. So this one is good because we've got the 2 heads there. This one as well, and this one as well. Are there any others? Oh, sorry. I was just trying to illustrate that that's how we got these sequences. Oh, I see. I see. Thanks, Sawyer. Okay, so we've got these 3 outcomes. How many total outcomes are there? Sorry. Yeah, 8 total outcomes and 3 favorable outcomes. So we can calculate our probability by going 3 over 8. And when we say this, this is our favorable outcome. You'll see this kind of language a lot. Favorable outcome, and this is our total number of outcomes. You'll see this language a lot. Our probability, our theoretical probability is 3 out of 8. And if you calculate that, what do you get? 37, about 37%. So our experimental probability was a little bit higher than that. Scroll up. Oh, the last page. Sure. So this is kind of exactly what we're saying here. The experimental probability we can calculate with NA, which is the number of times event A occurred. Okay, so whatever event we're looking at. So today we were looking at the event in which we had 2 heads, exactly 2 heads. So NA is the number of times event A occurred. You can also call this the favorable outcome. And NT is a total, okay? Total number of trials. The theoretical probability is very similar, but instead of going off of real-world experience and real trials, we do something like this, where we've got the tree to find out all the different outcomes and then figure out which ones are favorable. You don't always have to make a chart like that, no. So the theoretical probability, where NA is the number of favorable outcomes for event A, and NS is a total number of outcomes. So again, we've got favorable outcomes divided by total outcomes, and that gives us the total probability. And this is stuff that, at least so far, these are things that you kind of intuitively know. Like when you flip a coin, there are two possible outcomes, and your probability of getting a heads is 1 out of 2, or 1/2, right? One favorable outcome over 2 possible outcomes. And this is just defining an event. So the number of outcomes that satisfy specific conditions. So if we had to get a odd number, it could be either a 1, 3, or a 5. So the event is rolling an odd, and these are the possible outcomes. The probability of an event can range from 0 to 1. So you'll see this a lot. You can have a probability of, let's say, 0.3. 0.3. You can also call this 3 out of 10 or 30%. Okay, this is just an example. Okay? Probability is almost like always written as this in your math textbooks, as a decimal number between 0 and 1. And 0 means that it definitely won't happen. 1 means that it definitely will happen. 1 is like 100%. Any questions so far? Let's work on a few examples. So example 1A, visualize tossing a 6-sided die. What is the theoretical probability of getting a 5? So if we've got, when we roll a dice, how many total outcomes are there? 6, good. And how many favorable outcomes are there in this case? 1, okay? We're rolling a 5, and that only happens 1 out of 6. So this is our probability here, 1 out of 6. And you can write that as a decimal if you want. What is the theoretical probability of getting an even number? So again, our total outcomes is 6, and I heard 3 because there are 3 favorable outcomes. We can roll a 2, 4, or a 6. So that's 3 out of 6, or 1/2, or 50%, or 0.5, okay? There's a lot of different ways that you can write it. What is the theoretical probability of getting a number greater than 2? So when you say 4, what do you mean? 4 out of 6, okay? And how did you get that? Right, because there's 4 numbers greater than 2, so these are the number of favorable outcomes, and we've got 6 total again. So you can rewrite that as 2 out of 3, or about 66%, about, right? Or 0.6 repeated. So example 2 asks you if a game is fair or not. And a game is fair when both players, or all players, have an equal chance to win. So if you flip a coin and I win if it's heads, that's a fair game because we both have a 50% chance to win. We both have a probability of 1 out of 2 to win. How about number A? Number A, Matt and Pat each toss a coin. If the coins land as both heads or both tails, Matt wins. If the coins land as head and tail, Pat wins. So is this a fair game? Yes. All right, let me ask. Let's take a vote. Who thinks yes, this is a fair game? Okay, and who thinks no? This is not a fair game. Okay, so we've got a few in both camps. Let's do a quick chart here, okay? So we can do a head or tail for the first coin toss, and for the second, we can flip a heads or tails. And then we can take a look at all our outcomes. So we've got heads and heads, heads and tails, tails and heads, and tails and tails. So for Matt, or Mart, as his friends call him, he wins if both coins are heads or tails. In other words, if both coins are identical. So Mart would win if we've got these two here. And in the other case, when they're different, Pat wins. So we've got this one and this one. So they've both got 2 favorable outcomes out of 4. They've both got a probability of 2 out of 4 or 1 out of 2. So this game is in fact fair. Fair game. Fair game. How about this one? Trina, Lena, and Gina each toss a coin. If all 3 coins land as heads, Trina wins. If all 3 coins land as tails, Lena wins. Otherwise, Gina wins. Is this a fair game? No. Okay. So we've got Trina wins if it's heads, heads, and heads. And we already know from the chart before there are 8 total outcomes from this. When you're flipping 3 coins, there are 8 total outcomes. And how many favorable outcomes are there for Trina? 1. Okay, 1 out of 8 for Trina. How about for Lena? 1 out of 8 again. And how about for Gina? How many favorable outcomes are there? 6. How did you get that? Who's talking? Leah? Sorry, can you say that again, Leah? Exactly, and we can do that with probability. So we're going 1, our total probability is 1, and we're subtracting the probability that Trina wins, the probability that Lena wins, and we're left with 6 out of 8, or 3 out of 4. So this game is definitely not fair. Gina has a much better chance of winning. Her probability of winning is a lot greater. How about number C? Anne and Dan each roll a standard die. If the sum of the 2 dice is greater than 7, Anne wins. If the sum is less than 7, Dan wins. If the sum is 7, they tie. Is this a fair game? No? Yes? Let's take a vote. This one's a bit more complicated. There are a lot of different outcomes. There are 36 different outcomes when you roll 2 dice. 6 times 6, right? So who says yes, it's a fair game? Who says no, it's not a fair game? And half of you didn't vote. Let's work it out, okay? So if we've got if we can do our sums like this. We've got 2, 3, 4, 5, 6, 7. Okay, so these are the sums here. 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. 20, 12. And from here we can see who wins what. So if the sum of the 2 dice is greater than 7, Anne wins. So you can kind of see the shape here. All these ones here, these are the cases in which Anne wins the game. When the sum is greater than 7. So that was Anne. And if it's less than 7, then Dan wins. So that's all the 6s and below. And if it's 7, then they've tied. And I'll just circle that with black. Okay? So what is the probability that Anne wins? It is the same, right? So the probability that Anne wins is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 out of 36, sorry. The probability that Dan wins is the same, 15 out of 36. And the probability that they tie is 6 out of 36. So this is, in fact, a fair game. This is a fair game. Are there any questions about that? So that's 3.1. Let's move on to 3.2. We've been talking about probability, and probability is a favorable outcomes over the total number of outcomes. Take a look at the investigation. An oil and vinegar salad dressing is made using 2 parts oil to 1 part vinegar. So the ratio of oil to vinegar is 2.1, or sorry, 2 to 1, 2 to 1. What is the fraction, what fraction of the dressing is oil? What fraction of the dressing is oil? 2 to 1, that's the ratio of oil to vinegar, but what is the fraction? 2, is it 2 over 1? So now we're thinking about the total volume of that dressing, right? The total volume you can think of as 3. So the fraction of the dressing that is oil is 2 out of 3. So if you imagine you have a bottle and you're going to make this dressing, right? You might put in 2 cups of the oil, and then you would put in 1 cup of the vinegar, and you would get this 2 parts to 1 part recipe, right? And so you filled it up, let's say, to 3 cups, 2 of which are oil. Okay? This is kind of how we look at the difference between odds and probability. And kind of when we speak, we usually mean them interchangeably. Like, I've got good odds on this game. I've got a good probability of winning. And there's kind of a subtle difference between them, a subtle but important. So here we have the odds in favor, okay? Odds in favor. And the odds in favor, we usually write them in this kind of format here, in a ratio format. And the PA here, this is the favorable outcomes. So again, we're using that language, favorable outcomes, but in a different context. So favorable outcomes to, what is this here? What is that? Not A, good. So this is a complement, right? This is the probability of not A, okay? So for example, if we roll a dice, what is the odds in favor of rolling a 4? So what are the favorable outcomes? How many favorable outcomes are there? 1. Good. There's 1 favorable outcome. How many outcomes are, we can say, not favorable? Okay, so there are 6 total outcomes, but we have 5 that are not favorable, right? So this is a 1 to 5. The odds in favor are 1 to 5. So odds and probability are related, but they're kind of represented in different ways. This is our odds in favor. Similarly, the odds against, we can talk about the odds against, are given by kind of the opposite ratio. So what are the odds against? What are the odds against rolling a 5? 5 to 1, exactly. 5 to 1. And I'll write that here. Rolling a 4, we'll say. 5 to 1 or 1 to 5. Okay? So both of these talk about favorable outcomes and not favorable outcomes. Now, if I was looking at this, which shows our odds in favor, how can I use this to find probability? If I look at this, I see that there's one favorable outcome, and there's 5 unfavorable outcomes, or not favorable outcomes. So how many total outcomes are there? 6, which you can get just from adding both of these together. So our probability would be 1 out of 6. Okay? And that's kind of the relationship between odds and probability. So we talked about how probability is represented by a decimal number between 0 and 1. Whenever you have 2 possible events or multiple possible outcomes, those outcomes always add up to 1. That's a total probability. So if I roll a dice, I know for certain that I'm going to get some number, right? So I know that for certain. That's why we have a value of 1 as the total probability. The important thing when we're using 1 is that we can calculate probability of not A, or the probability of the unfavorable outcomes, by going 1 minus the probability of our favorable outcomes. And let's see that in an example. Okay. So the odds in favor, example 1, the odds in favor of Marcia passing her driver's test on the first try are 5 to 3. Actually, I think those are really good odds. I think it's probably worse than that. Determine the odds against Marcia passing her driver's test. So what are the odds against? 3 to 5. Good. 3 to 5. Easy. Determine the probability that she will pass her driver's test. Okay, I'm hearing it from a few places. This will be 5 over 8. Okay, so you add these two numbers together. That gives you your total. Okay, your total number of outcomes, right? So 5 out of 8. Bailey holds all the hearts from a standard deck of 52 playing cards. He asks Morgan to choose a single card without looking. Determine the odds in favor of Morgan choosing a face card. So how many favorable outcomes are there? Well, how many face cards are there in a standard deck of 52 playing cards? 12. Okay, good. So we've got 12 favorable outcomes. And how many, what would we put here? If we went 12, we would use 52 when we're talking about probability, right? So 52 is a total number of outcomes. That will be 12 out of 52. But take a look. This question is asking us to find the odds in favor. Exactly. 12 to 40. Okay? 12 to 40. Which we can simplify then to 6 to 20, 3 to 10. Okay? 3 to 10. You don't always have to simplify. I don't think so. So 12 is the total number of face cards in the deck. Okay, so Bailey holds all the hearts. Thank you. So you would start, you wouldn't even simplify it. Thank you. Yeah, so you'd start right here. We have 3 face cards. So those are your favorable outcomes, and the odds, the unfavorable outcomes is 10, right? Thank you. And example 3, a computer randomly selects a university student's name from the university database to award a $100 gift certificate for the bookstore. The odds against the selected student being male are 57 to 43. Determine the probability that the randomly selected university student will be male. So we know we've got 57 to 43, and this is our odds against. Okay, this is our odds against. So how would we find the probability? So remember, this odds against is defined like this. So the probability of not A to the probability of A. So how are we going to find, sorry, Leah? Okay, so if we go 57 over 100, remember this is our P not A, right? This 57 is our, right. Okay, so 43 out of 100. So you added these two together, right, Leah? So you can add these two together, and that'll give you your total number of outcomes. And just, so when you're working on a question like this, just double check, what are they giving and what are they asking for? So they gave you the odds against, and from there, you know you have to go to probability. And example 4. A hockey game has ended in a tie after a 5-minute overtime, so it's a shootout. The coach must decide whether Ellen or Brittany, oh, I see you are doing the question already, should go first in the shootout. The coach would prefer to use her best scorer first, so she will base her decision on the player's shootout records. Who should go first? Ellen. Who says Ellen? Who says Brittany? So let's figure it out. Okay. Yeah. So how did you do it, Sawyer? Okay. And why? Sawyer is absolutely right. So these are our total outcomes that we're considering. 13, 13 attempts. And out of those 13, she scored 8. So this is 8 over 13 and 10 over 17. Sawyer, can you tell me the can you okay, 65%. 59. Okay. So in this case, Ellen would be a better choice because she's better at scoring goals. Okay, so that was that. I know that's a lot, but this gives us a good start on this unit.